Hi, welcome back to our Road to Steam series, a series in which we'll be creating a game from scratch. Previously on our HEUSS Dev Diaries, we drew clouds to populate our skybox. In today's episode, we'll implement our clouds inside Unity. Interested to follow the progress of our game? Make sure to subscribe and hit the notification bell to get all the latest development updates every week. After multiple months of using a simple gradient as our sky, it's finally time to change things up and create a new skybox worthy of our game. But before doing any of that, we'd like to address an issue that was brought up in our previous episode. The problem in question can be boiled down to the fact that we traced over our reference images when we drew our clouds. We did this because in today's episode, we had planned to heavily transform them with things such as a blur effect, which would have made them drastically different from their original counterparts. From the start, we were always more interested in the general silhouette of the images, rather than the drawings themselves. However, you made us realize that we were in the wrong and that we should have used another method. So to rectify this, we decided to redraw all of our clouds to set the record straight. Here's the new look. With that out of the way, it's time to implement our skybox. We'll start by applying a blur effect on our clouds like we talked about earlier. We do this so that they can fit with our already blurred 2D environment. To accomplish this, we'll need to decide between three different techniques, each of them having their own pros and cons. Our first option is to use our depth of field effect we created in our 14th episode. It's a blur shader that we apply on a specific image, acting as an overlay that blurs anything located behind it. This technique allows us to easily blur an entire scene, but with one big caveat: the game's performance. Back then, when we were implementing dismemberment, we had to take a break from development to make some optimization on the project, as it was struggling to hit 60 FPS. During that time, we found out that this particular blur shader was the culprit behind the game's poor performance. Because of its graphical cost, we decided to abandon this blurring method. In its place, we went with a second technique we had up our sleeve. This approach boils down to manually blurring 2D assets inside Krita, and then importing them inside Unity. The big advantage with this is that it costs nothing on the performance side. However, it has two major cons. First, we cannot change the blur amount of an image once it's imported inside Unity. To do it, we need to repeat the whole process inside Krita. The second disadvantage is that we cannot scale an image without affecting its blurriness. Enlarging it softens its overall shape, while shrinking it sharpens its details instead. These two problems can be avoided with our third and final technique, a pixelation shader. At its core, this shader allows us to individually blur images to the amount we want by pixelating the sprites. It's not as pretty and performant as the previous method, but we can still scale the images while keeping the blurriness value intact. Each of these techniques have the pros and cons, so in the end, the choice comes down to what you're willing to sacrifice. In our case, we put performance and visual fidelity at the forefront. Because of this, we decided to go with our second method, the one where we manually blur images inside Krita. However, we're still not happy with the fact that we can't scale our images to our liking, so we've also decided to develop a neat little workaround. To circumvent our scaling problem, we first copy a particular cloud 4 times inside Krita. Each of these copies are then assigned a different size. When that's finished, we blur them to the specific amount we want. After this, we assemble them into a single object inside Unity, and we create a script to alternate between the different copies depending on which size that's needed. We then repeat the whole process for the 14 other clouds. Even though it's not the perfect solution, this will allow us to have some agency on the scale of our images without screwing up the blur value. With that done, it's now time to create our skybox. At the moment, we don't have a clear idea on which type of sky we want to implement. What we intend to do is experiment with different styles to see which one fits our environment the best. To accomplish this, we first need to set up our scene. This setup is meant to dynamically update the behaviors and visual aspects of our clouds. If everything is done correctly, all we'll need to do is drop them at a specific location, and they'll get automatically adjusted from there. In total, there are 4 properties that we're targeting. The movement speed of our clouds, their color tint, their transparency, and the point of teleportation. Each of these values change depending on their position in relation to anchors placed around the scene. Clouds closer to the green back anchor will be slower and more transparent, while those closer to the red right anchor will have a darker tint. Clouds that cross the green right anchor will get teleported back to the left green anchor to simulate a self-repeating skybox. With a powerful system like this, we have everything we need to create the sky of our dreams. Let's see what we can come up with for our first test run. With this first experiment done, we feel that our skybox is too flat looking at the moment. What we'd like to test out is to add subtle streaks in the sky to see if we can give it more personality. Something that you would find in a more cartoony skybox. To do this, we only need to draw 6 different silhouettes in Krita and import them inside Unity, where we'll change the color and scaling. Let's see how it all comes together. After this test, we've come to the conclusion that we won't use streaks in our sky. They create too much visual noise, making our skybox look like some of those bourgeois cappuccino they serve at Starbucks. Another thing we'll remove for the moment is the ability for our clouds to move from left to right. The reason behind this is because more often than not, clouds agglomerate in one big messy group, undoing the overall harmony of the scene. So for our final version for today, we'll go with a static sky combined with big fluffy clouds, something reminiscent of old Renaissance paintings. Now, let's see how it all comes together in action. Stay tuned for our next episode where we'll implement a camera shake system inside the game. Make sure to like, comment and subscribe, and we'll see you next week for the new episode of our Road to Steam series.